Thanks for joining me on a lesson on rates of change. Our target, calculate the average rate of change of a function. What's another word for average rate of change? What are some average rates we could find? Something per something. Very common one is miles per hour. If you're in Europe, it's kilometers per hour. Another one that's very common is dollars per hour. That's a rate. It's a wage. How about another one? Inches per year? Okay, no. Let's do zombies per day. Okay, so here's some data I collected over the recent 45 days. Time 0, this is the first day. 0 days have passed by. We have one zombie, 23 days, we just figured out, we collected some data. It's we now. I don't know, can't remember who. 150 zombies. And then, right around 45 days, we have 340 zombies. So as you know, they grow over time. And when they're in a certain city, there's only so much that only so many people that they could turn. So now that we got this tabular data, let's take a look at a question that we could have regarding rates of change. Let's say we want to use the points 23, 150 and 45, 340 to compute average rate of change. The average rate of change of zombies over time. So we're looking at this piece of data and this piece of data. Now this is a continuous function, it changes over time. So what I'm going to do is just graph this data so I could get a continuous function that we can analyze. So let's see here. Here's the data again. I'll zip to the graph. I actually plotted the points already. So I'm just going to graph a continuous curve. So here we have it. Day 0, we have one zombie, grows, day 23, about 150, it increases, and then it levels off. Let's take a look at how we can analyze this just graphically. So the question is, compute the average rate of change between 23 and 45, those x values. So what I can do is, let's see here, this is the 23 here, and I'll draw a horizontal line to 45 and a vertical line to 45. And now because that's a right angle, that the ratio of delta z for zombies over delta t represents the average rate of change. So let's write that. Let's see here, delta zombie over delta time. I messed up, but I fixed it. Here we go. So let's take a look at, okay, we go from 23 to 45, so that means delta t is 22. 22 days? Yeah. And then we go from 150 to 340, that means delta z, delta z is 190. So that means that delta z over delta t is 190 over 22. Okay, so I think we just found slope, which is also the same as the average rate of change, which is also the same as the slope of the secant line through those 2 points. Okay, this is not straight. And then I enter that in my calculator, and this is approximately 8.6 zombies per day. So that, my friends, represents the average rate of change of the zombies over time. Okay, that's great and all. All right, that was Algebra 2, Pre-Calc, whatever. Now, how fast? What if I wanted to know the answer to this question? How fast was the population growing on day 23? When t equals 23. That's where our slope formula fails us, but what we could do is we could consider some other points. Let's consider that instead of at day 45, comparing day 45 and day 23, we're going to compare day 40 to day 23. Hope you can see that would better represent the rate of change on that day than the other point. And then what's more, let's say we take, let's take this point and compare it to that point and see what the slope of that one is. So what we're doing really is changing that delta t, changing that h value. So let's set up the black curve, the slope for the black curve here. And then let's set up the green curve. So once we calculate the black stuff, let's see, we end up getting, 180 over 17, which is like 10.6 zombies per day. And then we calculate the other side, which is 115 divided by 7. Divide that out, and that's like 16.4 zombies per day. So okay, so then I could even go closer, and I could grab some other point on this blue curve, like say right there, and I can calculate the slope of that curve until that line basically becomes a tangent line. It's only touching the curve at one point. Okay, before I talk about that, let's go back just a moment here. So 8.6. So we went from 8.6 to 10.6 to 16.4. That's quite a big change. That's more than doubling. So what I'm seeing, the trend is it's approaching something around 17. Approaching 17-ish. Okay, sweet. So that's actually where we end up. We can't go any further with average rate of change. We need calculus to go further so that we could find the answer to this question. So we can notice from the data that there's no point that's closer that we can grab using the data that we're given, but we could do it based on the graph if we drew it accurate enough and we weren't just working from this cheap iPad program, so. But this was a graphical approach. If we were given an equation, we could calculate exact values and find the limit as h approaches 0, or delta t, I guess that was in this case, or delta d, delta x. Okay, so I guess the answer to our question over here is 17-ish. We need calculus. We need to know how to find the slope of the tangent line. So I will leave you with this question right here. What sort of continuous data would you be interested in analyzing? Go ahead and collect it somehow over the next day or two, and analyze it. See what you find out. Find out what the rates of change over something are. Maybe your bank account, maybe your parents' bank account, maybe your special trust fund. But that's about it. Thank you so much for watching. I believe we reached the target here, calculating the average rate of change of a function. Thank you so much.